Hello my schoolers, you're welcome to my school YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2024. Please do not go anywhere, stay with us and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we are going to be answering question 26 to 50. So let's kick off with question 26. A thick glass tumbler cracks when boiling water is poured into it because A, the inside expands more rapidly than the outside, B, the inside expands less rapidly than the outside, C, the expansion is even, D, it does not expand. So the answer to this question is option A, the inside expands more rapidly than the outside. And the reason for that is because when boiling water is poured inside a glass tumbler, the inside surface heats up and expands quickly, while the outer surface remains cooler and expands more slowly. So due to the difference in the rate of expansion, this creates stress in the glass tumbler leading to crack, okay? So that makes option A the correct answer to this question. Question 27. How much joules of heat are given out when a piece of iron of mass 60 gram and specific heat capacity 460 joules per kilogram per Kelvin cools from 75 degrees Celsius to 35 degrees Celsius? So let's move over to the board to provide answer to this question. So we know that quantity of heat Q is also equals to mc then delta theta, right? So when m stands for the mass of the substance, c stands for the specific heat capacity of the substance, and the theta here stands for temperature. So the delta here stands for change in temperature, okay? So but if you look at the specific heat capacity of the substance, okay, given to us, it is given to us in kilogram, whereas the mass in this question is given to us in grams. So we have to convert the mass in gram to kilogram, and to do that we simply divide the 60 kilogram by 1000. Okay, so if we divide 60 by 1000, we'll be having 0.06 kg. Okay, so here we just substitute the values to get the quantity of heat. Okay, but remember our change in temperature, okay, will be equals to 75 minus 35, right? So that will be equals to 40 degrees Celsius, right? Okay, so we just substitute the value. So here we'll be having 0.06 times 460 then times 40. Okay, so we can break this down further, right? So this is 460 and this is 40. If we divide by 10, of course we are still going to use it to multiply this. So if we use it to multiply, if we remove 10 from here, remove 10 from multiply together, that will be equals to 100. So if we use the 100 to multiply this, we'll be having 6 times 46 times 4, right? So if we multiply this together, we'll be having 1104 joules, okay? We're having 1104 joules. So the quantity of heat is equals to 1104 joules. So let's return back to the screen to pick the correct answer to this question, and that is option D, 1104 joules. Question 28. The energy of light of frequency 2.0 times 10 raised to the power 15 Hz is, so we are asked to take H to be equals to 6.63 times 10 raised to the power minus 34 joule second. Okay, so the H here actually stands for Planck's constant. So let's move over to the board to provide answer to this question. So in this question we are asked to calculate for energy of light. Okay, so energy of light E is given as frequency times H, right? So where H here stands for Planck's constant. So we just substitute the values that are given to us. So here we'll be having 2 times 10 raised to the power 15, okay, then times 6.63 times 10 raised to the power minus 34. Okay, so we multiply these two parts first so that we can apply the law of indices to solve this. So if we multiply these two parts, we'll be having 13.26. Okay, 13.26, then times 10 raised to the power minus 34, or better still, we can just write 15, then plus minus 34. So this will be equals to 13.26 times 10 raised to the power Okay, so if we subtract, you'll be having minus 19, right? But if you look at this is not a standard form, so we have to put this in standard form. And if you look at our options on the screen, they are all corrected to 2 decimal places. So we're also going to correct this to 2 decimal places. Okay, so but first of all, let's put this in standard form. So we are moving like this. And remember that in standard form, when you are moving from your right to your left, you usually add to the power. So if we move 1 here, we'll be having 1.326 times 10 raised to power. So since we are adding 1, we'll be having minus 18. Okay. Now, so let's take this to 2 decimal places. So if we take this value here to 2 decimal places, we'll be having 1.33 times 10 raised to power minus 18 joule, right? Since we are talking about energy. So let's return back to the screen to pick the correct answer to this question. And that is option B, 1.33 times 10 raised to power minus 18 joule. Question 29. A gas of mass at 40 millimeter mercury is heated from 298 Kelvin to 348 Kelvin at constant volume. Calculate the pressure exerted by the gas. So this is a typical question on pressure law. Okay, so we are going to be applying pressure law in solving this question. So let's return back to the board to provide answer to this. So from pressure law, we know that P1 over T1 is equals to P2 all over T2. So here we are required to get the value of P2, which is the new pressure, right? So we'll make it the subject of formula. So here P2 will be equals to P1 times T2 all over T1. So we just substitute the values that are given to us. Now, if you look at our temperatures, they're already given to us in Kelvin, so there's no need for us to convert, okay? But they were given to us in degrees Celsius, then in that case, we have to convert it from degrees Celsius to Kelvin. Okay, so let's substitute our value. So here we're having 40 times T2 is 348, then divided by 298. Okay, so if we multiply the numerator of this fraction and divide the result by the denominator, we are going to be having 46.71 millimeter of mercury. Okay, so let's return back to the screen to pick the correct answer to this question. Okay, and that is option B, 46.71 millimeter of mercury. Question 30. The distance between 2 successive crests of a water wave is 0.25 meters. If a particle on the surface of the water makes 4 complete vertical oscillations in 1 second, calculate the speed of the wave. Okay, so if you look at the question very well, we are told that the distance between 2 successive crests of a water wave is 0.25 meters. So that actually suggests the wavelength, right? Because we define wavelength as the distance between 2 successive crests or 2 successive troughs, right? Then another thing again from the question is that we are told that if the particle on the surface of the water makes 4 complete vertical oscillations in 1 second. Now remember that we define frequency as the number of oscillations per second. So in this case, okay, the frequency is equals to 4 Hz, right? So let's move to the board to calculate the speed of the wave. Okay, we know that the velocity of a wave or speed of a wave is related to the frequency and the wavelength by this equation. V is equals to F lambda. Okay, so in this case our F is equals to 4 because we are told that the particle on the surface of the water makes 4 complete vertical oscillation per second. Okay, and that actually defines frequency. Okay, and we know that our wavelength is equals to 0.25. So the speed of the wave in this case will be equals to 4 times 0.25. Okay, but remember that 0.25 is the same thing as 1 over 4, right? So 4 here is 1, 4 here is 1. So that at the end of the day, we have 1 left. Since we are calculating for speed, we know that the unit of speed is meter per second. Okay, so the speed of the wave is equals to 1 meter per second. So let's move back to the screen to pick the correct option for this question, okay? And that is option D, 1 meter per second. Question 31. The thermometer whose thermometric property is change in volume with temperature is A. We have the resistance thermometer. Okay, so the resistance thermometer measures temperature based on change in electrical resistance of a material with temperature. So that's not the answer to this question. While option B, we have the thermocouple. So the thermocouple consists of 2 bonded metals. Okay, it consists of two bonded metals, and these two bonded metals generate voltage that is proportional to the temperature difference between the hot and the cold junction. Okay, and that's not the answer to this question. Why option C, we have bimetallic thermometer. So bimetallic thermometer also consists of two bonded metals, and these two bonded metals have different rate of expansion. Okay, so this different rates of expansion of these two metals causes a bending motion that indicates temperature. Okay, and we have liquid in glass thermometer. So for the liquid in glass thermometer, this type of thermometer, they measure temperature based on change in volume of liquid with temperature, and that is the answer to this question, option D. Question 32. In a series resonant circuit, the current flowing in the circuit is A maximum, B minimum, C 0, and D unaffected. So the answer to this question is option A, maximum. Okay, and the reason for that is because in a resonant circuit, okay, the inductive and the capacitive inductors cancel each other out, right, minimizing the total impedance. This allows for maximum current to flow for a given voltage. That makes option A the correct answer to this question. Question 33. If a body in linear motion changes from point P to Q, the motion is translational. So for a translational motion, it's a type of motion in which a body actually moves from one point to another in a straight line without rotating. Okay, so we have B, which is rotational motion. So rotational motion is a type of motion in which an object rotates about an axis. For example, the rotation of the Earth around the sun is an example of rotational motion. While C, we have simple harmonic motion. So simple harmonic motion is a type of periodic motion where the restoring force is proportional to the displacement. While D is circular. So here, circular motion simply refers to the type of motion in which an object moves along a circular path. So the answer to this question is option A, because option A is what is described in the question. So when a body moves in a straight line or in a linear motion from one point to another without rotating, we have the type of motion referred to as translational motion. So that makes option A the correct answer to this question. Question 34. Which of these gas laws is equivalent to work done? A, we have Charles' law, B, we have pressure law, C, Boyle's law, and D, Gay-Lussac's law. So the answer to this question is option C, Boyle's law. Okay, and the reason for that is that if we want to calculate for the work done or by a gas, we normally use the formula pressure times change in volume, and this pressure times change in volume is fundamentally tied to Boyle's law. So that makes option C the correct answer to this question. Do you know you can take practice question with our JAMB CBT past question? All you need to do is to click on the link in the description below, and that will take you to my school website. There you have to download my school mobile app for your Android devices and my school software for your laptops and computers. Please go ahead and start practicing. Moving on to question 35. The process of adding impurities to a semiconductor material to increase its conductivity is A, rectification, B, emission, C, doping, and D, stabilization. Okay, so the answer to this question is option C, doping. So doping is the intentional addition of impurity to a semiconductor, okay, to a semiconductor material to improve its electrical conductivity. Okay, while option A, rectification, just the process of changing or converting AC current to DC current. While B, emission, is the process of releasing energy in form of particles. While option D, stabilization, is just the process of making a system stable, often by reducing fluctuation. But remember that the answer to this question is option C, doping. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video. Question 36. A load of 300 Newton is to be lifted by a machine with a velocity ratio of 2 and an efficiency of 60%. What effort will be applied to lift the load? So let's return back to the board to provide answer to this question. So the efficiency of a machine is given as mechanical advantage all over velocity ratio times 100%, okay, or times 100. Now remember, in this question we are told that efficiency is equal to 60%. So here if we have our 60 over 100, which is 60%, then we'll be having it to be equal to the mechanical advantage, since we are calculating for effort. And remember that mechanical advantage is equals to load over effort. So we need to calculate for this first, okay, then before we can now calculate for the effort, whichever way anyway. So here, velocity ratio is given to us to be equals to 2. So there's no need for this 100% again because of the over 100 here. So we just cross multiply. So if we cross multiply, okay, 0 will cancel 0, then we cross multiply. So if we cross multiply, we'll be having 12. Okay, we'll be having 10 m dot a to be equals to 12, right? So we divide both sides by the coefficient of the mechanical advantage, so that mechanical advantage is equals to 12 divided by 10, and that is equals to 1.2. Okay, so now that we've calculated for mechanical advantage, then we can now move ahead to solve for effort. Now, since our mechanical advantage is equals to 1.2, so we'll put 1.2 here, and the load is given to us to be equals to 300, right, all over effort. So we make the effort the subject of formula because that is what we're actually calculating for. So we just switch the position of the 1.2 and that of the effort. So effort now becomes 300 divided by 1.2. Okay, so remember that 1.2 is still the same thing as, say, 12 all over 10, right? So our 3000, then we change this to times, this is over 1, then we change this to times, so you'll be having 10 all over 12. Okay, so we divide. So 6 here is going to give us 2. 6 into 30 is going to give us 5. So we still have 500 left, right? So 500 times this is going to give us 5,000. Okay, 2 here is going to give us 1. 2 here is going to give us 5. 5 times 5 is going to be equals to 25, right? Okay, so the value of the load that is given to us was 300, sorry, not 3,000. Okay, so here we'll be having 50. So 50 times 5, that will be equals to 250 Newton. Okay, so the effort needed to lift the load of 300 Newton is 250 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option C, 250 Newton. Question 37. The average translational kinetic energy of gas molecules depends on A, temperature only, B, number of moles and temperature, C, pressure and temperature, D, pressure only. So the answer to this question is option A, temperature only. So the average translational kinetic energy of a gas molecule is directly proportional to the absolute temperature of the gases. Okay, going by this equation, kinetic energy of a gas is equals to 3 over 2 kT. Okay, where T stands for the absolute temperature, while K stands for Boltzmann constant. Okay, so from this formula we can see that the average translational kinetic energy of a gas is directly proportional to the absolute temperature. So that makes option A the correct answer to this question. Question 38. The fourth overtone of a closed pipe is 900 Hz. Its fundamental frequency is, so let's move over to the board to provide answer to this question. So one thing we must take note of is that for a closed pipe, only odd harmonics exist, okay? And the first overtone is equals to 3 F naught, where F naught here stands for the fundamental frequency. Okay, so if the first overtone is equals to 3 times the fundamental frequency, okay, while the fourth overtone will be equals to 9 F naught. So in this question we're told that the fourth overtone 9 F naught is equals to 900 Hz, right? That we should look for the fundamental frequency. So what do we do here? We simply divide both sides by 9. So F naught is equals to 900 divided by 9, and this will be equals to 100 Hz. Okay, so the fundamental frequency where the fourth overtone is equals to 900 Hz is equals to 100 Hz. So let's return back to the screen to pick the correct answer to this question, and that is option B, 100 Hz. Question 39. A cell of internal resistance of 2 ohms supplies current through a resistor X If the efficiency of the cell is 75%, find the value of S. So let's move over to the board to provide answer to this question. So these are the parameters that are given to us in the question. So the resistor that they are referring to actually is the external resistor. Okay, so the efficiency of a cell is given as external resistor, okay, all over external resistor plus internal resistor times 100. Right, so with this formula we can calculate for the efficiency of a cell, but in this question the efficiency of the cell is given to us as 75%, so you're right, 75 over 100. So here they said the resistance is X, so you'll be having X all over X plus 2 for the internal resistance, right? So we just cross multiply, or let us just divide. So if we divide here by 100, we're having 0.75 being equal to X all over X plus 2. So we cross multiply. So if we cross multiply, we'll be having S. Okay, so if we cross multiply, we'll be having 0.75x, then plus. Now 2 times 0.75 will be equals to 1.5, and this will be equals to x. Okay, x times 1, that will be equals to s. So we just collect like terms. So if we collect like terms, we'll be having x minus 0.75s to be equals to 1.5. Okay, and this will be equals to 0.25x being equal to 1.5. So since we are looking for x, okay, since we are looking for x, we divide both sides by the coefficient of x, which is 0.25, so that x is equals to 1.5 divided by 0.25. Okay, and 1.5 is the same thing as 15 over 10. Okay, so divided by, and 0.25 is the same thing as 25, okay, over 100. Okay, so let's break it down further so that we can divide without using calculator. So here we'll be having 15 over 10, then times 100 over 25. Okay, so 0 we cancel out 0, 5 here will be 5, and 5 here will be equals to 2. So 5 here will be 1, and 5 here will be 3. So that at the end of the day, the value of S is equals to 3 times 2, which is equals to 6 ohms. Okay, so the value of S is equals to 6 ohms. So let's return back to the screen to pick the correct answer to this question, and that is option C, 6 ohms. Question 40. In voltage measurement, the potentiometer is preferred to voltmeter because it A, has a wider range, B, consumes negligible current, C, is bulky, D, responds faster than voltmeter. So the answer to this question is option B, consumes negligible current. So the potentiometer is preferred to voltmeter in voltage measurement because the potentiometer does not draw significant current from the circuit being measured. So that makes option B the correct answer to this question, consumes negligible current. Question 41. Which of the following is the best as shaving mirror? A, concave mirror, B, convex mirror, C, plane mirror, D, parabolic mirror. So the answer to this question is option A, concave mirror. The reason is because concave mirror can produce magnified image, allowing for a closer view of the face. Now apart from that, the concave mirrors too can focus light to a point, okay, making them ideal for detailed tasks such as shaving. Okay, while option B, convex mirror provide a wider field of view but produces a smaller diminished image, while option C, plane mirror provides a true to size reflection but does not magnify image, although it can be used as saving mirror, but it is not as effective as concave mirror, while the parabolic mirror is not practical as shaving mirror. So the answer to this question is option A, concave mirror. Question 42. A refrigerator uses 150 watts. If it is kept on for 336 hours non-stop, what is the energy consumed in kilowatt hour? So let's move to the board to provide answer to this question. So energy consumed or energy consumption, or energy expended or energy used is equals to power times time. Okay, but this our power must be in kilowatt. So we have to convert this to kilowatt by simply dividing by 1000. So if we divide 150 by 1000, we'll be having 0.150 kilowatts. Okay, so here we just substitute and multiply. So E is equals to the power, which is 0.150, okay, times 336, right? So if we multiply this together, we'll be having 50.40 kilowatt hour. Okay, so the energy consumed in kilowatt hour is equals to 50.40. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option B, 50.40 kilowatt hour. Question 43. What is the inductance reactance of a coil of 7 Henry when connected to a 50 Hz AC circuit? So let's move over to the board to provide answer to this question. So we usually calculate inductance reactance XL using the formula 2 pi FL, where F stands for frequency and L stands for inductance. Okay, so let's just substitute the values that are given to us. So XL will be equals to 2 times, of course, our pi is 3.142, then times frequency, which is 50 times 7. Okay, so if we multiply these 4 numbers together, we'll be having 2199.4, okay, 0.4 ohms. Of course, to the nearest whole number, we'll be having 2200 ohms. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 2200 ohms. Question 44. If a charged ion goes through a combined electric field E and magnetic field B, the resultant emergent velocity of the ion is, so let's move over to the board to provide answer to this question. So for the ion to go through a combined electric and magnetic field without deflection, the magnetic and electric field must be equal. So know that our electric field F is equals to QE, while magnetic field, let's represent it with FM, is equals to QVB. Okay, since both of them are equal, we're having QE being equal to QVB. So Q on both sides we cancel out. Since we are looking for the value of V, we just make the subject of formula by dividing both sides by B, so that V is equals to E divided by B. Okay, so this is the value of the emergent velocity. So let's return back to the screen to pick the correct answer to this question, and that is option A, E over B. If you have any question, please feel free to ask your question by clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution providers will provide answer to all your questions within a short period of time. Moving on to question 45. In electrolysis, when same quantity of electricity is passed through different electrolytes, mass of substance is deposited is proportional to. So this is a question they are trying to test your knowledge of the second law of electrolysis. So A, we have molecular weight, B, we have chemical equivalent, C, we have atomic number, and D, we have chemical equivalent per valency. So the answer to this question is option B. So according to Faraday's second law of electrolysis, the law states that when the same quantity of electricity is passed through different electrolytes, then the mass of substances deposited is proportional to the chemical equivalent of the substance. So that makes option B the correct answer to this question. Do you have better solution or steps to any of these questions? If yes, go to the comment section below to comment the question number and the solution you wish to share. Question 46. If the rate of evaporation is Y and the rate of condensation is S, then a vapor is saturated when S is greater than Y, B, X, C, S is equals to Y, and D, S is less than or equal to Y. Okay, so a vapor is said to be saturated when the amount of vapor entering the gaseous phase is equal to the amount of vapor returning to the liquid phase. So in essence, I'm saying that when the rate of evaporation is equal to the rate of condensation, then we can say that a vapor is saturated. Okay, so that makes option C the correct answer to this question. S is equal to Y. But remember that X is the rate of condensation and Y is the rate of evaporation. So vapor is saturated when the rate of condensation is equal to the rate of evaporation, or when the rate of evaporation is equal to the rate of condensation. Question 47. The degree of precision of a vernier caliper is A, 0.005 centimeter, B, 0.01 centimeter, C, 0.1 centimeter, and D, 1.0 centimeter. So the answer to this question is option B, 0.01 centimeter. So the degree of precision of a vernier caliper is 0.01 centimeter. So this simply means that the vernier caliper can make measurements to the nearest hundredths of a centimeter. So that makes option B the correct answer to this question. Question 48. According to kinetic theory of gases, the pressure exerted by the gas on the wall is equal: A, change in momentum per unit volume; B, rate of change of momentum imparted by the walls per second per unit area; C, momentum imparted to the walls per unit area; D, change in momentum imparted to the wall per unit area. So the answer to this question is option B. According to the kinetic theory of gas, the pressure exerted by the gas on the wall is equal to the rate of change of momentum imparted by the wall per second per unit area. So the reason for that is because when a gas strikes a wall, when a gas molecule strikes a wall, the gas molecules exert a force on the wall due to change in momentum. Okay, so that makes option B the correct answer to this question. Question 49. The property by which a material returns to its original shape after the removal of force is called A, elasticity; B, ductility; C, malleability; and D, plasticity. Okay, so the answer to this question is elasticity, because elasticity is the property by which a material returns to its original shape after the removal of force. Okay, while option B is ductility. Ductility simply describes the ability of a material to be drawn into wire, while option C, malleability, simply describes the ability of a material to be beaten into sheet. Okay, while option D describes the ability of a material to remain permanently deformed without, or to undergo permanent deformation without breaking. Okay, but the answer to this question is option A, elasticity. Question 50. The energy in a moving car is an example of A, mechanical energy; B, electrical energy; C, potential energy; and D, kinetic energy. So the answer to this question is kinetic energy. Kinetic energy simply is the energy possessed by a body by virtue of its motion. Okay, and the energy in a moving car is an example of kinetic energy. While option A, mechanical energy exists in form of potential and kinetic energy, while electrical energy is another form of energy, but the energy in a moving car is not an example of electrical energy. So the answer to this question still remains option D, kinetic energy. Why? Because the car is in motion, and the energy possessed by a body in motion is referred to as kinetic energy. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.